Hello guys, welcome back. In this video, we'll be solving Leetcode Biweekly Contest 122, problem 3rd. It is 3012, minimize length of array using operations. So in this question, it's given that we'll have one array nums. It will contain positive integers. We can perform this operation. What is this operation? That we can select any two distinct indices, okay, and such that they are both positive, and then we can perform one calculation that nums of I modulo nums of j, and whatever we will get the result, we'll push it back at the end of nums, and then we can delete this, or we should need to delete this both the indices I and j. So you can see that we are deleting two elements and we are just inserting one element. So eventually we are reducing the length of this nums array. So the question is, what can be the minimum length of this nums after any performing this operation any number of times? Okay, let's see this one example. So first of all, it is saying that there are a bunch of numbers 1 4 3 1. It is saying that we are selecting index 2 and 1, that is this and this. Okay, then we are inserting nums of 2 modulo nums of 1, that is nums of 2, that is 3, and nums of 1 is 4. 3 modulo 4 will be 3. So we are inserting, then array became something like this. Then we will have to delete the element at both these indices. So we'll be deleting this element. So it become 1 1 3. Then it selected 1 and 2, that is 1 and 2. So the array became this, and then we deleted the indices 1 and 2, and then array becomes this. Now if we'll select these two elements, we'll have nums like that is both the elements are equal to 1, so their modulo will be equal to 0. Inserted 0 at the end, then we will be deleting this 2 and this is. So finally the length has become 1. Okay, so in this scenario the minimum length is possible is 1. Okay, so I hope you got the question. Now there is a very important point to note down over here. So you are saying that we have to select I and j two indices, right? So just let's say if we are selecting two numbers x and y. Okay, so if we'll see the value for x modulo y, okay, we know that if y is less than x, y is lesser than equal to x, then it can have 0 till y minus 1 as answer, right? If y is less than x. But if y is greater than x, in that scenario it will always result as x. I'll repeat, listen carefully what I'm saying. If y is smaller than x, then we'll have 0 to y minus 1 as its answer or as the remainder. But if y is greater than x, then in that scenario we'll always have x as our answer. I hope this would give you a little bit of intuition. So let's say if we had numbers something like this 1, 2, 3, 4, 5, something, anything. So what we can do? Let's say if this is 1, we'll take this 2. So what will happen? If we'll take this 2, we'll have to insert its modulo, that is 1 modulo 2, that will result as 1 at the end. So we can insert 1 at the here, and then we'll have to delete it. Then again what we can do is we can select this as again this number and this number. Then in that scenario we'll have 1 modulo 3, and again we'll insert, this will result in 1. Then we can insert 1 over here. Then we'll have to delete two this. So we have selected this and this, so we'll exclude them. Then again let me rewrite this. Then we have 4 7 1. Then again we'll select, let's say 4 7 and 1. Then again it will result in 4 7 1 1, and then we'll have to delete these two indices. So we'll delete them, then it becomes 4 and 1, and again finally 4 and 1 result to some one, right? Because in this scenario we are taking 1 as the first element and 4 as the second element. So I hope you got the idea. Like if x is smaller than y, then it, sorry, yes, x is smaller than y, then we will always have x as answer. Okay, now so if we have our array, so what we'll do, what will we do? So now let's say first of all we'll calculate its minimum element. Why are we calculating minimum element? You will understand in a minute. So first of all we'll calculate its minimum element, let's say m. Now we know that in this entire array we have m as the minimum element. M is the minimum element. Okay, but if somehow we can have one number which is smaller than m. Let's say m minus 1 or m minus 2 or m minus 3 till 1. Okay, let's say if somehow we can have one number, then we know that we can reduce all these numbers to an array of length 1, whatever the value we have right here. How how because let's say we know that if we'll pick any number, let's say x, from this array, we know that this x will definitely be greater than whatever number we have here. So whether it's m minus 2, m minus 3, anything, whatever we'll pick from here, that will be smaller than this x. Why? Because we know that m was the smallest element. That means m minus 1, m minus 2 will be smaller than this m. That means this, whatever the value, let's say we are picking c from here, then this c will be smaller than all the elements. So if we'll calculate something like this c modulo x, keeping like we are picking this x from this array, then it will result in c. And eventually we'll whatever c, like I will pick c from one index and x from some another index. Eventually we'll delete them, that, and we'll insert c at the end. That's what the operation is, right? So you'll see carefully that c is remained as it is, though it changed the position, but that doesn't matter because we can pick any x, I and j. But this x is deleted. So eventually what will happen, we will delete all the numbers, only this c will be left in the end. So in those scenario, we'll have 1 as our answer. So let me repeat this. If we have somehow one number which is lesser than m, and if we'll see carefully, this is nothing but, see, something modulo m will result in this one, right? So what we'll do, we'll just run a loop, okay, over all the elements with modulo m. So all the elements with modulo m. And if it is not equal to 0, okay, if it is not equal to 0, that means it will be equal to 1 or 2 or 3 till m minus 1. Why? Because we know that if we'll take modulo with m, its remainder or its result will always be from 0 to m minus 1. And we know that if except 0, if there is any number, why except 0? Because in the question it is mentioned that whatever number we are picking, that should be positive, right? So we cannot choose 0. Now if there is any number you using which we can get a number smaller than m, then we know that in this scenario our answer will, we can simply return 1. Why? Because we can reduce this entire array to a length of array of to an array of length 1, using the property that if x modulo y is equal to x, if y is greater than x. Okay, and we know that this, whatever we will choose from 1 to m minus 1, that will be smaller than all the numbers on this. So eventually we'll start deleting one by one, and we'll finally have one, whatever we have. Let's say if we selected c from here, so in the last we'll have just c as the only element in this array. So in those scenario, we can simply return 1 as our answer. But if that is not the case, then what does it mean? It means that all the numbers in this array are a multiple of m. Listen carefully. If this condition does not satisfy, that none of the elements modulo m give results other than equal to 0, that means all the numbers are divisible by m, then only remainder will be 0, right? So that means all the numbers are multiple of m. Okay, multiples of m. Now multiples of m, that, what does that mean? if if it is a multiple of m, then what will happen? See, we already know that if there is any number, let's say if there are two numbers x and y, and if y is greater than x, then we can get this y deleted. How? I mean, in our question also, if we'll use the operation, we know that x modulo y will result in x, then we will insert x at the end of this array, and then we will just delete x and wherever this x and y. So ideally what we are doing, we are just deleting the bigger number. So we know that eventually we can delete all the numbers except the m's, except the m's. So finally what will happen? Only m will be remaining. Why? Because if we'll select just 2m, if we'll just select 2m, it will return 0. And if there is any number which is greater than m, let's say 2m or 3m or 7m, anything, then if we'll select this m and this number, then this number will get deleted, because this taking this m modulo 2m will result in m, will insert m at the end, and we will delete this 2. So ideally we are just we are deleting one m and we are adding one m, so m is there, but we are just deleting this 2m. So eventually at the end we will have just m's left. Okay, now let's say if there are 4m, then what will happen? We can take these two, and this modulo m will return equal to 0. We'll insert 0 at the end and we'll delete both these two. Similarly, we can take these two m's and we can add 0. So what we realize, but let's say if there was one more m, then we cannot do anything. So what does we can see from here is that we can just have a count of the smallest number, we can have a count of the smallest number, and we can have the floor, sorry, seal of that value divided by 2, or simply whatever the count we have, we can simply add 1 and divide it by 2. So here it is 5, it was 5, then 5 plus 1 divided by 2, that is equals to 6 by 2, that is equals to 3, that 3 elements will be remaining. And we can also see that this both resulted in this 0, and this 2m resulted in this 0, and this there was 1m left, and we cannot choose these two zeros, right? Because in the question it was mentioned that we cannot choose zeros. Okay, so I'll repeat again what is the final solution. So first of all, what we'll do, first of all we'll calculate the minimum element, let's say m. Okay, then if there is any element, we can simply run a for loop. If there is any element such that its modulo is not equal to 0, then we have found it some element which is less than equal to m minus 1, okay, or lesser than m. Then in this scenario, if we'll pick this c, we can delete all the elements, and finally this c will remain, so we can have our length 1 as answer. Else what we'll do, we'll just count the frequency of this and we can simply return count plus 1 divided by 2 as our answer. Okay, I hope this would be, and yes, the most important property here which we are using is x modulo y is equal to x if y is greater than x, and also this one, that's not important, this was the most important. Okay, I hope this would be clear to you. Let's go see the code. Okay, so first of all we calculated the size, then we calculated the min element, and we have a variable for its count. Now we are checking that if at any place this c modulo this minimum element is not equal to 0, that means we found one number which taking modulo will return another number which is smaller than this minimum element, and using that smaller number we can reduce this entire array to size of or to length of 1. Okay, so we can simply return 1, else we are just keeping count of the minimum element. And if this condition got never satisfied, then we will come out of this loop and we can simply return count plus 1 divided by 2 as our answer. Okay, let's try submitting this solution. Okay, it's an accepted solution. I hope this would be clear to you, but if you guys have any doubt, ask me in the comment section. Okay, thank you guys, see you in the next video.